Welcome. Today we'll talk about the different types of network topologies. There are different topologies such as bus topology, ring topology, star topology, mesh topology, and also the hybrid topology. We'll discuss about these different topologies in details, the types of devices and the physical connectors, cables which are used for these topologies, and also their benefit and losses. Bus topology. Bus topology is a type of network wherein every computer in the network is connected to a single wire. At the end of the wire, there are two different connectors, which is also known as the BNC connectors, terminates the wire end. So as you can see in this topology, we have a single wire here, which connects all these different computers. There are different types of cables which are used, and the connectors which connect here is also known as the T-type connector. The connectors which ends the wire or ends the topology is also known as the BNC connectors. Some important functions of the bus topologies are that the data can only be transferred in the one direction. That means if computer A has some data to send to computer C, it can send the data in this direction. So while the data is being transferred this way, none other computer can send the data in the other direction like this. This is not permitted in this. And also this is important to know that all the data which is sent in using the bus topology here can only be sent one by one. In other words, one computer can send the data at a time. If the second computer has to send the data, it has to wait for the first computer to finish, and once the first computer is done with sending all the data, then only the second computer will get a chance to transfer the data. And the other function of the bus topology is that every device is connected to a single wire, as we discussed. Some common advantages and disadvantages of the same topology is discussed in the further slide. Some of the advantages of bus topology and disadvantages we'll be discussing in this slide. So let's start with the advantages for now. The first advantage is the bus topology is cost effective. That means it is cheaper to configure or install this topology as compared to any other topology that we have in the networks or that we have available. The second advantage is that the cables which are required for this topologies we need less than any other topology that we use. Let's say we have one cable and we can use 5 different computers. We can connect all of them to this single wire. However, in the other topologies, we'll be discussing it a little later, that if we have 5 computers to use, we need more cable than this one. Now, the third option that we have, which is the advantage of this topology type is good for a small environment. That means if you have computers or if you want to build a network with hundreds and thousands of computers, this would not be a good option to opt for. The fourth advantage of this one is that it is easy to understand. That means that the data flows in through one wire only in this topology, and you know how the data is processing. Since it's a limited, it connects the limited devices together, and it's easy to understand and maintain the network topology. The last is, but not the least, advantage is it is easy to expand this topology. That means we have one wire which is connecting 5 different computers here. And now we are in need of expanding the network with 2 more computers. So what we will do, we'll expand this wire, we'll attach a new wire, we'll connect that wire with the existing one, and we'll add two new computers here. So this is as easy to expand this particular topology. Now let's discuss about the disadvantages of the same. So the first disadvantage of this is the single point of failure. That means that the entire network, all the computers are connected with each other using a single cable. If in case this cable fails, the entire network will not be able to communicate with each other. So we have a single point of failure. If this goes down, the entire network goes down. The second disadvantage of the same is if the network traffic is heavy or the user has more to send, the network will become slower. In that case, let's understand it this way, that computer A, which is connected at this point, wants to send some data to the computer B, which is connecting at the end of the topology. Now computer A has a file of 25 MB, 25 MB here that it wants to send. And there's another computer connected in the topology who wants to send the data at the same time. However, as discussed, that one computer can send the data at a time only. So this computer will first finish sending all the 25 MB data first, and once it is done, then only this computer will get a chance to transfer the data. But now just think about this situation wherein this computer likes to send a file of 2 GB to the sender. In that case, since we have only one medium to send the data, this computer will have to wait a little longer. And let's think that if we have third computer in the row as well who wants to send the data. So after sending the 2 GB data, the information will be passed to this. Now this computer will send, and again if it has 2 GB files again to send, this computer will have to wait for this one to send the data, to complete sending the data. So in that case, the heavier network, or if you have more to send, the computer has to wait more. And the third disadvantage is the cable has its own limit. That means the cable that we are using, it has its limits up to which we can expand or extend the cable. The fourth and the last disadvantages of this is it is slower than the other topologies like ring topology and the other topologies that we have, such as mesh and star topology. Ring topology, also known as token ring topology, as the name defines. In this, all the computers are connected to each other and they form a kind of ring circle to communicate with each other. In this topology, there's a concept of virtual token. This token is a virtually defined into the topology and keeps moving in this direction. So what happens, how this topology works? Let's say computer A would like to send some data to computer C. In this topology, the data can only travel in this direction. There is no medium or an option that this computer can directly send the data in this direction, because this C computer is just one hop away if it uses the other direction. So if computer A has some data to send, how it does? Once the token ring, there's a token which moves around all these computers which are connected to each other. The computer who has to send the data will reserve the token and will start sending the data. The other computer, in case has anything else to send, it will have to wait for the computer A to complete the transfer, and then only it can start the transfer after that. So in this case, once the token reaches this computer will reserve the token and will start sending the data in this direction. And while the computer A is sending the data to computer C, meanwhile the computer F here has some data to send right now. So this cannot send the data unless the token is released from computer A and it reaches the computer F. So once the computer A is done with sending all the data, it releases the token and token starts moving forward to the next hop. The token reaches this computer here. This computer checks if it has anything to send. At this time, this computer does not have any data to transfer, so it does not reserve the token and move it forward. Once the token reaches the computer F will again reserve the token and will start forwarding the data to the destination. This is how the token ring topology or the ring topology works. Ring topology features. Let's talk about some common features provided by the ring topology. The first feature is that ring topology can also use the repeaters. Repeaters are basically used to regenerate the signals so that the data loss on the path can be avoided. The second feature in the ring topology is that you can expand the topology by using the two separate cables as ring. So this is also known as dual ring topology. Let's assume we have a computer connected with one ring topology. I'm sorry for the bad drawing. And we have another computer connected with these two. The limitation in the ring topology is that only one computer can transfer the data at a time. However, you have an option to create another ring for these two computers and connect the same computers to these two rings. So by having this dual ring topology, this computer can use this particular wire, which is the inner one, to send the data, and at the same time the second computer can use the external wire to send the data at the same time. So this feature is provided by the ring topology only. Now let's talk about some advantages and disadvantages of the ring topology. The first and the foremost advantage of the ring topology is that it can send the data on a higher transmission, like it can send the data faster than the bus topology, as we discussed earlier. The second advantage of this is it is cheaper and convenient to install it. So it's very easy to install the ring and connect the computers the same. And the second, let's talk about some disadvantages of the same. The disadvantages of the ring topologies are like the troubleshooting in this is difficult. Let's assume we have one ring wherein the 5 different computers are connected to the same. So these 5 different computers, if in case something happens, we'll have to bring down the entire network and then only we can troubleshoot it. The one thing that we need to know about the ring topology is that if one node or one computer in the ring topology goes down, the entire network will go down, because this computer, which is not working at the moment, will not be able to pass the token ring to the next hop, and unless the next hop gets the token, that computer will not be able to transfer any data. The second disadvantage of the same is addition and deletion of the computers in this network is difficult, because if you'll have to take down any computer out of the network, that will be very difficult. You'll have to break this connection from here, and you'll have to bring down the entire network, and you'll have to manage also the downtime for the same. Without it, it won't be possible. And the third one is, as discussed, that failure of any one computer in the network will bring down the entire topology. Star topology. This is the topology which is commonly used in this era. Star topology is a kind of, it forms a star wherein we use a centralized device such as hub or a switch, uh, and we connect all our computers to this centralized device. And all of them can have their separate connections or the separate wires to connect to this centralized device. And this works in this mode, that if in case any of the device, let's say computer A, goes down, it won't affect any other computer in the network. So as you can see that we have a centralized device and all the devices are connected to the same. It forms a kind of star formation, and that's why it's called the star topology. Features of the star topology. The first feature of the star topology is like every node has its own dedicated connection in order to connect to the network. So let's assume we are using a hub for the centralized device, and this hub is connected to 5 different computers in the network. So all the computers will have their separate and dedicated wire to connect to the network. It is not possible that you can use one wire to connect to 2 different devices. And the second feature of the same is the hub can act as repeaters to flow the data. That means that in the earlier topology, such as ring topology, we were using repeaters, a separate device, to regenerate the signals in order to transfer the data or to avoid the data loss on the path. But here, when a computer sends the data to repeater, the repeater will regenerate the same signal and will forward the data to the destination on the other end. The third feature of the same is it can be used, this topology specifically can use different types of cable such as twisted pair, fiber optical, or the coaxial cable. You have the different options to use the different cables and connect the different devices. Let's talk about some advantages of the star topology, and we'll also discuss the disadvantages of the same. The first and the foremost advantage of the same is it performs in a better way. That means it travels the data with faster speed as compared to the other two topologies that we discussed earlier. The second advantage is the hub can be upgraded easily. The centralized device that we have, we can arrange this downtime for some time and we can upgrade the hub. We can use the newer version of the hub, or also we can change the centralized device such as hub with the switch. So these facilities are available in the star topology only. The third advantage of the same is it is easy to troubleshoot. That means if we have a centralized device connecting the multiple devices together and one particular device is facing the issue now, so we'll not have to bring down the entire network. We can only focus at this connection and it becomes an easy for us to troubleshoot the same. The second is easy to set up and modify. That means if we have the requirement to expand the network, we just need to have the available ports here on the hub or on the centralized device, and we can add the new computers, or we can also delete the existing computers from the topology without even impacting the existing topology or the existing network. Some of the common disadvantages of the same are there's a cost involved in this installation. That means as compared to the other previous two topologies that we have discussed, the installation of such type of topology is a little costlier, or you'll have to spend a little more in this topology. It's expensive to use, as we said that every node would have their separate connection, and you'll also have to use a centralized device to manage the network topology. So you'll have to spend a little more to maintain this topology. The third one is if the hub fails, then the entire network will stop. So again, this centralized device that we have, this is the single point of failure. If in case, due to any reason for hardware or software, the centralized device goes down, no computer in the network will be able to communicate with each other. This is the major disadvantage of the same. However, apart from all these disadvantages, still star topology is the most famous and commonly used topology at this time. Mesh topology. Mesh topology is an advanced topology, or in this topology you can say that every node will have their separate connection to other node in the network. That means that every computer will be connected to each other with a separate wire or a separate connection. Let's take an advantage of this A computer. This has a link going to this computer, which is computer B, and then this also has a different link to which goes to all other computers in the network. So as you can see that every node, every computer in the network will have a separate link in order to connect to the other computer in the network. In this type of topology, I would like to explain that this type of topology is only used when there's a very crucial data that you'll have to spend, that you have to in the network to share, and also if the data or the privacy. Let's talk about some advantages of the mesh topology. The first and the foremost advantage that I would like to discuss is that each connection has its own data to carry. That means that every device in the network has their separate connections and they can send the data separately. This also increases the privacy in the network. The second advantage of the same is the fault tolerance or the fault diagnostic is easy in this topology. Let's assume you have two computers connecting to each other. These computers are not able to communicate with each other. You don't have to focus on any other connection. You can simply focus on this particular connection on this particular wire. If you have to change it, you can change this one, or you can focus on the troubleshooting between these two. So the fault tolerance in this is pretty easy as compared to the other one. The third is it provides security and privacy. As discussed that since every computer would have the separate connection to the every single device in the network, the privacy enhances by this feature, and also it avoids the possibility that the data can be hacked in between on the path. Some of the disadvantages of this topology are like heavily cabled. As you know that there'll be possibly 10 cables in the or the 10 devices in the network. So as you can understand, since 10 devices in the network will have to connect to each other, so every device will use the separate cable for the same. So there'll be a mesh of the cable and it would be really difficult to manage that for the administrator. The second disadvantage of this is that it involves a lot of cost. Of course, since we'll be using a lot of wires and the devices in this, so it costs us a more as compared to the other two topologies or the three topologies that we have discussed. Hybrid topology. This is the last topology that we'll be discussing in this video. The hybrid topology is the combination of two different types of topologies that can be used, such as you can see in this picture, that we are using a ring topology here and a star topology here. And we are connecting these two topologies with a centralized device, which can be a hub or a switch. So there might be possibility that you have two different requirements in the office, wherein you want to connect some devices in the ring format and the other devices in the star topology. So what you can do is you can combine these two topologies together, and together they are called as the hybrid topology. The working functionality for them would remain same. So if these two computers have to communicate with each other, they'll have to wait for the soft token or the virtual token in order to transfer the data between them. However, if this computer has to send the data to some other computer which is connected into the star topology, so it can directly send the data out to the centralized device, and this can send the data to another centralized device which will forward it to the final destination this way. So the individual functionality of these two topologies will remain same. However, they'll still be able to communicate with each other using the centralized device as we have here. To talk about some of the advantages of the hybrid topologies are like, it's more reliable and easy to troubleshoot because we have two different topologies connecting and you can focus on one topology at a time if you're facing any issues. This is more scalable and can be increased. That means that you can go ahead and expand your network easily using the different type of topology. Let's say you want to expand the network, you can simply add the device into the centralized device if you're talking about the star topology, and on the ring topology you can also add the device there, but for the ring topology side you'll have to take the downtime. Some disadvantages are like, it's complex in design because since there are two different topologies are involved in this, so sometimes it becomes a little difficult or hard to understand the same and to troubleshoot it. The second disadvantage is it is costlier than any other topology because you'll have to spend the money for two different topologies, and also you'll have to purchase a separate individual centralized device to connect these topologies together. So it's little costlier as compared to the other topologies that we have discussed in the other slides. Thank you for watching. This is the end of the video, and I'll be coming up with more videos on different topics of the CCNA. Thank you.